Greetings, this is Terry Endicott again, and what I want to do is actually state and prove the short Five Lemma, which we start talking about. I just sort of set up the stage. I didn't even have a chance to say what it is. And it's actually this little guy right here, and I'll go into it in a little bit of detail. At the top we have an exact sequence, and the bottom row we have an exact sequence. For example, the two exact sequences I used in the last video, A and A prime, or A prime and A, was actually the cyclic group of order 3. C prime and C was the cyclic group of order 2. B prime I had as S3, the first, the smallest, shouldn't say first, but the smallest non-abelian group. And B is was a cyclic group of order 6, or Z2 cross Z3. Same thing. So, obviously, those guys weren't really related. This in the example I gave, this is an isomorphism, this is an isomorphism, etc. Okay, so now with the short Five Lemma, you have two exact sequences like this. A prime is isomorphic to A, C prime is isomorphic to C, and we have a commutative diagram here and here, and B prime is there's a map from B prime to B, so these diagrams commute. And what that means is that if I take something in A prime, and I go over here to alpha prime of A prime, and then I come down by my little phi here, have phi of alpha prime of A prime, which is sitting in B, or I can go down like this by my isomorphism alpha, lambda, have my little lambda, 1/5 each IV of A prime, and this goes on over by alpha, this was alpha prime here, to a alpha of applied to a lambda of an A prime. And if these two guys are actually equal, say the diagram commutes. In other words, this commutes if I go the same going, and of course sound effects are quite important. So we want those two diagrams to commute. Now the conclusion, and you're going to hold your breath because I don't know if you'll see this coming, the conclusion is that B prime is isomorphic to B. Okay, everybody cheer, bring out the champagne, etc. Very surprising, wasn't it? Which is why I wrote EGADS, my book. You have enough hypothesis to kill a horse, and guess what? Poor horse is dead. And actually, but the funny thing is this lemma sort of pops up every now and then. I hope to get to a couple examples. I won't be able to do it in this little lecture, but I'll give you a couple examples of where he used it. It's sort of my non-standard examples. Okay, let's prove it. Let's do the onto first, and let's let a little BB down here. What I want to do is work down here the way I just did with the commutative diagram demonstration, because this is so cluttered up, it's just be a total disaster looking at it. Yeah, on a big whiteboard it's not so bad, or a blackboard or something traditional. So let's go down here with a B. And what we want to do eventually is find a B prime that clobbers onto it, or something in B prime that clobbers onto it. Okay? And there's not a whole lot we can do with that B right now. Let's just send it over to C here, see what happens. So that's beta of B. And that's in C. Well, C is isomorphic to C prime, so I can back that up. And I'll still have the arrow going on in the same direction here, because the way the diagram commutes, but we can back that up into some sort of C prime here. And I'll just call it C prime because we're going to get bogged down with a whole bunch of things. And since this sequence here is exact, there's B prime that gets mapped onto that C prime, and it goes on down to this B, beta of B. Now, it'd be nice if that B prime went down by phi to B, but it probably doesn't. There's no reason to believe that it hits the B. I'm sorry, that's just phi there. Phi, phi, fo, fum. Phi of B is down in here. Phi of B prime. There's no reason to believe that these two are equal. Okay? In general, they probably aren't. However, let's just see what happens when we take this over. This goes like this, and this thing goes over to here, right? So, if we take the difference of that thing, that will go to 0, and that difference will be back in A. In other words, B minus phi of B goes to 0, so it's in the kernel of beta, image of alpha. Whoops, I don't want an equal there. So that means there's a little A over here that goes onto this difference. Well, this is an isomorphism, so I can take and back that A up to an A prime here. And then I can shove this A prime over by alpha prime. And this is alpha prime of A prime. And I run out of room to put stuff. A bit shorter. This is alpha prime, A prime. So let's just see what happens when I throw that down. Is that a candidate? Well, almost, but not quite. Alpha prime of A prime goes down and hits this difference. Aha! Our candidate, so we have one B prime goes down to here, this alpha prime A prime goes down to here. If we add these two up, we get B. So what we want to do is take phi of B prime plus alpha prime of A prime. That will equal this guy here. Well, B goes to this, just the phi of B here. Phi of B prime, rather. But this goes to B minus phi of B prime. We're done. Okay, that's on to. And believe it or not, that was the hard part. Okay, I'll do the easy part. Okay, we want to show that this map is one-to-one. So the easiest way of doing that in general, of course, is to show that the kernel of that is 0. So let B prime be in kernel of phi. Okay. So we'll have our go back down like this again. B prime, and it goes down to 0 here. That's all we know so far. And we'd like to back it up to here, but we don't even know if it's going to be in the kernel of this map yet. So let's just send it over here, and this goes to some C prime, which is actually equal to beta prime of B prime, of course. Let's send it down here, and the only place it can go is 0 because this diagram has to commute. But this is an isomorphism, so the C prime, which is equal to beta of this B prime, has to equal 0. So that means that B prime itself is in the kernel of beta prime, which means that there's a guy back here, some sort of A prime, that maps onto that B prime, because the exact sequences. Okay, we take this A prime, we go down to some A, which is actually lambda of A prime actually, and we send that on over. This diagram commutes, so that means that A gets mapped onto 0, but alpha is 1 to 1. Alpha is 1 to 1. This forces A to equal 0. Lambda here is an isomorphism, so that forces A prime to equal 0. Well, then if A prime is 0, the only thing that A prime can map onto is 0. This forces B prime, which is the image of A prime, to be 0. Bingo! We're done. That wasn't even painless at all, was it? Okay, so now we have the Five Lemma, all proven. Now the next time what I want to do is talk a little bit about this guy here, sort of, in the middle of a short exact sequence, and I want to actually show, using the Five Lemma, a very simple proof that the external direct sum is isomorphic to the internal direct sum. Also, I probably won't be able to include it in the same lecture, but I want to get away from groups themselves and actually look at vector spaces and show a neat way that you can prove that the dual space of a finite dimensional vector space is isomorphic to the vector space. Now, some of you who are quite familiar with dual spaces, or fairly familiar, will say, well, you can't do that because arrows flip around. I'll talk about what that means actually. It has to do with a thing called a contravariant functor, but there's a way around it, and you probably already figured that out. Sure. But anyway, that is it for now. Have a great day.